Hi there. Today I would like to look at proving that functions are indeed inverses of each other. A little bit of information that I need you to learn is that if we compose two functions, and let's call it f of x and g of x, if the result of that composition gives us the value of x, then that in itself is proof that f of x and g of x are inverses of each other. So if you're ever asked to work out two composite functions and the result is x, then because the result is x, that means that those two functions are direct inverses of each other. So in this case, in the grey box, if I was to work out f of g of x, and if I got x, it shows me that f of x and g of x are inverses, so that f of x is equal to g to the minus 1 of x, and g of x is equal to f to the minus 1 of x. It would also work out if I worked out g of x. I would get the exact same result. Example 10 here, you might recognise example 10. Example 10 is very similar to example 9a that we did in the previous set of examples. In example 9a, we asked you to find the inverse function for f of x is equal to 2x plus 5. And lo and behold, we got g of x is equal to x minus 5 all over 2. Or in the example it said f to the minus 1 of x. But let's actually prove that g of x is in fact the inverse of it. So like I said, to prove that one function is the inverse of another, all I need to do is compose the two functions together, i.e. find f of g of x. You could find g of f of x, it would give you the same result. I've just chosen to find f of g of x. So let's do that then. So let's take g of x and substitute it into f of x. So that would give me 2 brackets x minus 5 over 2 close bracket plus 5. So let's cancel the multiplication of 2 by the division of 2. That will give me x minus 5 plus 5. The minus 5 and plus 5 cancel out, so I'm left with x. That in itself is the proof. Because I've composed those two functions and my final result is x, that is proof that one function is the inverse of another function. In higher maths, you will see a lot of questions that finish off or that have got a bit in it that says show that or prove that. And it's vitally important that you finish those questions off correctly. So this question said show that g of x is equal to f to the minus 1 of x. Well, we've shown that, so we can say therefore, since f of g of x is equal to x, then f and g are inverses of each other. So g of x is equal to f to the minus 1 of x. So that questions should always have a little sentence at the end just to round things off. So let's just sum up what we've got here. We've worked on finding inverse functions. So to find an inverse function, all we do is change subject to make it say x, and then change the terms about. But you can also use this proving technique that we've just done here to see if you're getting the right answer when you're asked to find an inverse function. So, for example, if we were to look back at the previous examples in question 9, A, B, C, and D, if you were to take the question, I'm just looking here at example C here. If I was to take P of X and also take my answer that I've got here, P to the minus 1 of X, if I was to work out what P of P to the minus 1 of X is, i.e. take P to the minus 1 of X and substitute it into P of X wherever we see an X, if I do that correctly, then the result should be X. And if it is X, that is the proof that I've done my inverse, my change subject process correctly there.